afternoon, one and all. Good afternoon. Some of the problems, subject name is compiler reading. We have completed with some of the problems which are related to code optimization and code generation. Now, in this also, we will take up some of the problems which are related to optimization and generation problems. So, now let us take a new example which is having the addresses and modes which are to be involved or to calculate the cost. So here this table is used mainly for the purpose of calculation of this one. So what is the absolute address which has the mode? That is here absolute with form, that is memory registers, and registers. So here in this example, let us go on with an example. Move R0, M. In this example, move R0, M. Now the instruction selection, that is what is the cost association? That is instruction cost equal to 1 plus cost associated with the corresponding registers and memory locations. Okay. Now, in this case, let us see with in this example, as per the table. So that's why before example, we have taken as a table with the corresponding modes: absolute addressing mode, register addressing mode, indexed addressing mode, indexed indirect register, indexed addressing mode. So this one is memory and registers contents of R, pointer registers and star with contents of R. Now in case of address, memory registers contents of R and C plus contents of R, that means here the pointer notations with this one. What is the cost association for the memory? It is 1. Whereas registers it is 0, and indexed registers of the contents 1, indirect registers 0, and indirect index contents are 1. So the program instruction sequence which contains of the, here in this example, the registers and what is the register? Register is R0 and memory location is M. Register is R0 and memory location is M. So as per the table, how the instruction cost will be identified. Instruction cost equal to 1 plus cost association. Here in this example, the R0 is given, M is given. So move R0, M. Now instruction cost equal to 1 plus instruction cost equal to 1 plus cost association of register and memory. So that is equal to 1 plus cost association of register plus cost association of memory. Now in this 1 plus, what is the register cost association? 0. And what is the cost association? Memory 1. So 1 plus 1, 2. Now as per that's why the individual units of the corresponding instruction is to be calculated as well. Now that is the formula. Instruction cost is to be defined as 1 plus cost association with the source and the cost association with the destination address. This cost is nothing but the length of the instruction. It is also specifies a length of the instruction. What is the address modes which involving the registers? So here the cost is 0, registers is 0. What is the cost involving address modes which are having memory location? It has the cost 1. So instruction strength is must and should be minimized because the space is important. So because our many statements, many instructions require several number of registers which requires storage space. So that's why we have to minimize as many as possible, so that the length of the instruction length and the time taken instruction length and time taken, both are to be considered. If instruction length is minimized, automatically the space is to be consumed, very less consumption, and the time is also reduced. So both the time and space, instruction length is to be carried out the cases depends on both space and then time. So many number of instructions which leads to lot of addresses, registers and memory locations and contents of that one, and automatically the time to perform that each of the instruction, that is also takes some amount of time. So these two factors affecting this one. So we have to minimize as per that requirement. In this example, we are considering one example here. The three address statement is given, that is A equal to B plus C. Now this A equal to B plus C can be implemented in a different variety of sequence of the instruction formats. That is R0 is the register which is initially, that is moved to B, that is, and then add, we are going to add into C, that is B plus C, and place in the contents. Again the result is stored in A, so A equal to B plus C. This is one sequence, and directly without using the register also we can write this type of instruction as move B comma A. That means what is the contents of A, that is to be moved to the B, and we are going to add move B plus C. That means that means previously contents are available in B. Now just we are adding to C in the next instruction, that is B plus C, and result which will be, that is assigned. So here instead of registers also we can write the execution selection instructions in the same format. But what is the cost association in this example of each of the instruction? So here the cost association for this one instruction cost equal to 1 plus cost association with the B plus cost association with the register. So now you get 1 plus 1 plus 0, that is equal to 2. Similarly for this one also instruction cost equal to 1 plus cost association with C plus cost with the register. So you'll get 1 plus cost, so that is 1 plus 0, that is equal to. Now in this case instruction cost equal to 1 plus cost association with register plus cost association with A. Now here 1 plus 0 plus 1, now that is equal to. So now 2, we are getting 2 plus 2 plus 2, that is equal to 6. So individual instruction formats we are getting the each one 2 to length, and together we will get the cost is 6. But here if you observe in this case the cost association, instruction cost equal to cost plus B, that is in this case instruction cost equal to 1 plus cost association with B plus cost association with A. Now that is equal to 1 plus 1 plus 1, that is equal to 3. Now it is same as there is instruction cost equal to 1 plus cost of C plus cost of A. Now 1 plus 1 plus 1, that is equal to 3. So now 3 plus the what, here each individual limit 336. Now this cost is 6 for in this one, both are, but whereas the time utilized for this one will be more, taking more time compared to this compared to this next instruction loading this one. So this is to be saved as per the previous also. The two parameters that is affecting, what is space, another one is time. So instead of registers we can without registers also. And also length of the instruction, length of the instruction also. Here how many 3 instructions are to be passed with several registers, with the registers or not, and but here 2 instructions are to be written without any registers. So that is to be 2 factors that is to be considered as instruction length with space and time. So in this example A equal to B plus C. So this is the assignment statement which is to be considered. both the assignment statement, both two cases taking the same instruction cost, but the time wise and instruction length and space according to them term it varies. So that is to be considered based on. So here, suppose in this example, we are going to assume some registers are not R1, R2, and the addresses of that is A, B, and C. Now here, in these two cases, um, what is the cost associated for this? Why? Because here this is the 0, 1 plus cost is equal to 1 plus 0 plus 0. So that's why it is 1. Whereas in this case also, instruction cost equal to 1 plus 0 plus 0. Here also 1. Now the cost association is 2. Yeah, it is 2. Whereas here the cost association with this one instruction add R2 comma R1. So that is also instruction cost equal to 1 plus. Here 1 is to be used for the purpose of instruction. So that's why the instruction cost is to be included with this one as well. So add instruction, move instruction. What is the instruction that is to be applied? That is to be considered plus registers 0 plus 0, that is 1. And here in this case, cost equal to 1 plus the register 0 plus 1, so that is 2. So this is the cost is 3. So here assume that R1 R2 contain the values of B and C. Assume that R1 R2 contains the values of B and C, so that the value of B is not needed after the assignment. If we use that one, then it will be storage point of view, it is to be increased only. So that's why if it is required, then we can. So here value of B is not needed. So that's why here we can directly write R1 comma A. So in order to generate the good code for the target meditation, we utilize addressing capabilities efficiently. So where the requirement is really necessary, that is to be carried out with the corresponding addresses of the and the followed by the register. So if not required, then we no need to use for that as a separate assignment. If the used separately, then it leads to the instruction length, storage space, and time for executing this one leads that one. So that is the main important factors. Now we are going to see that what is a basic block. Previously we have seen the basic block, which contain a block of statements which is to be executed for several number of times. It depends on the loop. Say for example, here in this example, a basic block is given. So this is to be considered as x equal to y plus z, a 3 address statement. Now the block has to be contain one statement, that is each inside the block, each statement is to be written as a separate 3 address statement. So T1 equal to A star A is one 3 address code statement, and T2 equal to A star B is one 3 address code. T3 equal to, if any instruction which doesn't contain, then make into that 3 address. So this is an example of 3 address statement. X equal to Y plus Z is an example of 3 address statement. And T4 equal to T1 plus T3, T5 equal to B star B, T6 equal to T4 plus 5. Now that is the code that is to be available. So we make them into and maintain a break. So here all the statements which are to be used in this one must and should be a 3 address code statement only. Otherwise, split that into use another intermediate or temporary variable, temporary names such as T1, T2, as many number of this one as per the requirement. So in this example, we required that's why we used this. So here T1 is A star A, and T2 is A star B. Now T3 equal to 2 star T2. What is T2? A star B only. Now T4 equal to T1 plus T3. What is T1? A star A. T3 is 2 star A star B. Now T5 equal to B star B. T6 equal to T4 plus T5. A star A plus 2 into A star B plus T5 B star B. Now this is the given statement. This statement is to be addressed into a 3 address code notation with the basic block. So we have defined several temporaries and make use of this as this one. So like this we can perform various 3 address code statements in this basic block and follow the flow graph notation where edges and transitions takes place. These nodes of the graph represent these basic blocks with the assignment statements only, and later we can make use of transition from moving from one node to another node. That is the case of representing the flow graph implementation. Okay, all the contents which we can available in this book. Thank you. Next, we'll come up with one more topic with a new problem solving technique in code generation.
Like, share, and subscribe. Hit the bell icon for more updates.